Hello, welcome back to physics. Our next problem involving motion with a constant acceleration goes as follows. A car is going 80 kilometers per hour in a 50 kilometer per hour speed zone. So this car's speeding, right? When the car passes a police car, the police take off at an acceleration of 8.0 meters per second acceleration to catch up to the speeding car. Two questions. Number one, or part A, how long does it take for the police officer to reach the same speed as the car that's speeding down the road? And part B, how far away from the car is the police car when he matches the speed? So you have a situation, you have to read these problems and you have to read them usually a few times to understand what's really going on, because if you just dive into, it's very common to just take these numbers and try to stick them into some equations and get something. But let's take a minute to understand what's happening. You've got a stationary police officer. He's not moving. He's parked on the side of the road. And then you have a car that's speeding. Now the problem tells you it's going 80 kilometers per hour in a 50 kilometer hour zone. That just tells you he's speeding, and we know the speed of the car, 80 kilometers per hour. So the car is coming down the road. The police officer is the marker. The car is coming down the road. He passes the car. At this moment that he passes the car, it says right here, when the car passes the police car, he takes off at an 8.0 meter per second squared acceleration. So at that point, the speeding car comes, and at that point he passes up the cop, but then the cop starts to accelerate to try to catch up. And the problem's basically asking how long in seconds does it take. It doesn't say how long for the cop to catch the car, to catch up to him. It doesn't ask you that. You got to read it carefully. How long does it take for the police to go the same speed as the speeding car, so to match speeds? Second part is how far away from the car is the cop when that actually happens. So we always need to draw a picture. Even though we just talked about it, I want to draw a picture just to make sure we understand. We have our equations of motion. I'm going to leave them on the board for all the problems, either the same ones we always use. So here you have a speeding car. So I'm going to call this a speeder. But you all know it's a car, right? And we're told in the problem statement that he's got a velocity of what? It says 80 kilometers per hour. 80 kilometers per hour. Now right away, if you don't catch it when you read the problem, or initially, if you write it down, immediately you need to know kilometers. We don't want those in physics problems. Typically, we want meters. So we're going to have to convert, and we don't want hours either. We want meters per second. So we know we're going to have to convert. But for the purpose of our diagram, let's go ahead and just put the speed down because we do know what it is. All right, now this the speeder has been coming down the road, you know, he's been speeding the whole time, and at this moment, he passes a police car. So I'm going to put police under here. And just in case you forgot, this is also a car. Right? Now, initially, I don't even want to put an arrow here, because really what's happening is the police car, the initial speed at time 0 is actually 0. In other words, the cop is not moving, right? But as soon as the speeder passes him, I'm going to go and draw an acceleration vector, because he starts to accelerate at 8.0 meters per second squared. So you see his velocity is 0, but at that moment when the policeman slams on the gas, at that moment his velocity is 0, but his instantaneous acceleration at that moment pushes him in a seat, and then for the rest of the problem, he's accelerating at a known constant acceleration, which is 8. So at this moment, they're lined up exactly, and we can call this time here, t equal to 0 seconds, at this moment when the cars are basically lined up. And then every second that ticks after that, the cars are going to be in different positions. So you can do it however you want, but the way I